What's going on, guys? It's Physics Master 1229 here, back with another video, and today we're going to be covering the physics behind a basketball free throw.
Meet the natural on the basketball court. He's the free throw king of the world. Just watch this guy shoot. You might think 54-year-old Bob Fisher is a former NBA star or a basketball coach. Nope, he works for the U.S. Department of Agriculture. Bob and his wife Connie live in Centralia, Kansas. Population 500. So how did this regular Joe get so good at free throws?
About 20 years ago, I heard the advice, become an expert in something. Pick one small area and become an expert in that area. And for me, that was shooting a basketball.
He built this contraption in his basement to perfect his shot.
He gets up at 6:30, goes downstairs on his little contraption, and he shoots. And so it's thunk, thunk, thunk.
And
Basketball was first played in 1891 and was invented by James Naismith on a rainy day as something to do indoors. It started out by shooting a ball into a peach basket, as seen here, and has since evolved into a much more modern sport. From kids in parks all across the globe and pros like James Harden and Steph Curry in the NBA, it has since become a staple of American civilization and an iconic sport played all throughout the world. And like all things in life, many fundamental physics principles govern how the ball swishes into the hoop in a perfect free throw. So shooting a basketball is very similar to throwing any other projectile. It too follows an upside-down parabolic trajectory in the air. It starts from a certain vertical distance up, which is about the height of the person's head, as the ball rests in the shooter's right hand on their right side of their face, or whatever their dominant side and hand are. The ball has both rotational and translational kinetic energy as it is spinning up into the air. After the shooter pushes up their arm and gives the ball an applied force by bending their knees and springing up, the ball rolls out of the hand, causing the ball to spin backwards as it moves forward, following an upward arc in the air. This spin is caused by friction with the hand. The speed of the backspin, along with the applied force from the shooter, launches the ball up and forward before the gravity brings the ball down into the net. In an ideal situation, right when the ball is released from the hand, it has both vertical and horizontal velocity. However, whereas the horizontal velocity stays constant for its entire route, the vertical velocity decreases until it reaches zero at the apex. This is because of its constant downward acceleration caused by gravity, which is negative 9.8 meters per second squared. Gravity continues to decrease its vertical velocity until it's negative by this point here. All three of Newton's three laws apply to this situation. For the first law, the ball doesn't move without your applied force. As far as the second law goes, F equals ma, the more massive the shooter is, the more force they need to spring their body up and deliver the ball to the basket. As far as the third law goes, of equal and opposite reactions, there are several action-reaction pairs in this scenario. For example, the ground pushes back up on the shooter and the ball pushes down on their hand. So how do you make the ball go right where you want it to into the hoop? Aside from basketball techniques like aiming right in the middle of the hoop and holding the ball on the dominant side of your face, the physics behind it is reliant largely of the launch angle of your throw. The perfect launch angle is different for everyone depending on their wingspan and vertical distance from the ground, but in order to have the best chance of your ball going into the hoop, you need to ensure that it is moving as slow as possible when approaching the basket. This is to give you the best chance of the ball softly bouncing off the rim and into the hoop, rather than bouncing strongly away if the ball misses the hoop, and no one has perfect aim. So shooting at a 45-degree angle maximizes both your vertical and horizontal velocity. You need to minimize horizontal velocity but retain enough vertical velocity to get the ball to the basket. So raising your shooting angle is your best bet, as this will decrease horizontal velocity. This is proved mathematically because cosine decreases, cosine is the blue dotted line here, as you raise your shooting angle. And right here is 45 degrees, so that is where you can maximize both horizontal and vertical. But you need to shoot around here, a little less than 90 degrees, and obviously this is going to be different for everyone. And increasing your shooting angle will decrease your total velocity, so it will also, you need to increase your applied force, because this will also decrease the distance the ball travels, as seen by this equation. So that's it for today, guys. We're going to be back here again tomorrow with another video, and I'll see you then.